Sass Class with Amanda. Hey. So in this video we continue our discussion on probability, specifically conditional probability. Right, so now we're dealing with dependent events, whereas before we dealt with independent or disjoint events. So the way we write this is the probability of an event B occurring given an event A has occurred is equal to the probability of A and B occurring over the probability of A occurring. So if we're just looking at, here's S, here's A, here's B. So if of the occurrence of A, okay, so we're looking at some proportion of A in which B also occurs. Okay, so A has to occur first, which is why we're looking at a proportion over the probability of A, and then B has to occur as well. So we are essentially looking at the intersection of A and B, but what proportion of A does B also occur? Okay, I hope that makes sense. All right, so the way you'll see this notated is probability of B with a vertical bar. This vertical bar means the word given A. So the probability of event B occurring given A has occurred is equal to the probability of A intersect B, because remember this cap is the same thing as the word and, over probability of A. Alright, so that is the formula for conditional probability. Now let's put it to some good use. Alright, so here we're considering all colleges and universities, and we're looking at the degrees earned. Okay, so 50% of degrees earned are bachelor's degrees. 59% of degrees earned are earned by women. And 29% of bachelor's degrees are earned by women. So these all sound the same, but they're all different. Okay, this is talking about the population of degrees and the subpopulation of bachelor's degrees. Okay, so imagine we have this pot. Here's a pot. Let's pretend it's a witch's pot. Alright, so this pot is the pot of degrees. Alright, and so let's say there are PhDs, there are masters, and then there are bachelors and associates. Okay, so we're talking about all colleges and universities. Those are the 4 types of degrees you can get. So P is for PhD, M is for masters, B is for bachelors, and A is for associates. Alright. Now we want to figure out the percentage of degrees earned by women. So, assuming that by women they mean gender identity, right? I'm just going to break this up into female, male, and non-binary, right? So in another color, you would be breaking up all degrees into 3 sections, right? So here are 3 sections. So here's male, female, and non-binary, right? So, and 29% of bachelor's degrees. Now we're looking at bachelor's degrees are earned by women. So you would even cut this bachelor's degree up into 3, and you would have male, female, and non-binary, okay? And so 29% of that, so there are multiple percentages and multiple subsections happening here. So just be careful with the wording, because with conditional probability problems, it's very easy to get lost. If it helps to draw a witch's cauldron, you're more than welcome to do that. What is the conditional probability that a randomly selected degree is earned by a woman given it's a bachelor's degree. So pay attention to this word given. It tells us what order things go in. Okay, so just remember that we have the rule, probability of B given A is equal to the probability of B intersect A over the probability of A. So from this question, we want to determine what is B and what is A. Well, a randomly selected degrees earned by a woman is going to be B, so the probability that a degree is earned by a woman, so I'm going to say degree by woman, given it's a bachelor's degree, so bachelor's degree. So that's equal to the probability that the degree earned by a woman and it's a bachelor's degree over the probability that it's a bachelor's degree. Okay, so since we have percentages, we could just take advantage of that and turn those into probabilities. So the probability that a randomly selected degree is a bachelor's degree, we know is 0.5. Okay, and the probability a bachelor's degree earned by a woman is 0.29. Okay, and so that should equal 0.58. Hopefully that all made sense. So something else to note about this conditional probability is that A and B are independent if this conditional probability is equal to the probability of B. And that's because when they're independent, this intersection is equal to the product of P of A times P of B. And so what happens is that this cancels and you're just left with P of B, right? So if we ever want to determine whether two events are independent, we can do that mathematically. And so we'll do that here. Are the two events, degrees earned by woman and degrees earned are bachelor's degrees, independent? So what did we look at? We looked at, in the previous example, probability of degree earned by woman given bachelor's degree, so P of W given B, and we want to show that probability that a degree earned by a woman is independent of degrees earned are bachelor's degrees. So we want to show that this, not B, but I want this to be W. We want to show that this is equivalent. So we saw that this is 0.58 from above, and we know that the degrees earned by women are 0.59. This is not close enough, right? So this implies that they are not independent.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peek. so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so narrow, 110. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.